We are looking at 6. Woo woo.
How many more do we have?
We are solving equations. All right, so there's two types of equations that we're going to be solving here. All exponential equations, so the variable is going to be in the exponent. Go ahead. Yeah, we got it. Not much of a pencil left, but I'm kidding. I'm just joking. All right, so let's try this out. I'm gonna draw. Let's just cut this bad boy in half. Cut him in half, and by half I meant 60/40. Yeah, let's go with 3 raised to the 4x minus 5 is equal to 27 raised to the x plus 1. And we got to go solve for x. Okay. So first things first, we got to take a look at this guy. What is the base on the left-hand side? 3. What is the base on the right-hand side?
27.
Can I write 27 in terms of 3 to some power? What is it? 3 to the third, right? So we end up with 3 raised to the 4x minus 5 equals 3 to the third raised to the x plus 1. And now, looking at our exponential properties, when I have a power raised to a power, what do I do with those powers? When I have a power raised to a power, what operation do I use on those powers? Multiply. When I have a power to a power, we're going to multiply. So, 3 to the third raised to the x plus 1, I have to multiply 3 with x plus 1. So we end up with 3 raised to the 4x minus 5 is equal to 3 raised to the 3x plus 3. Now, do I have the same base?
Yeah.
Same base means, how am I going to write this? I ran out of room. Same base means that we have the same exponent. Right? So if a to the x equals a to the y, then x must equal y. So now that I have the same base on the left-hand side as I have on the right-hand side, all right, 3 to some power, 3 to some power. All right, so a to some power, a to some power, we let the exponents equal each other. So my next line here, now that I have the same base, my next line is going to say 4x minus 5 equals 3x plus 3. And now this is very easy to solve. You've been solving these things since 8th grade, maybe even 9th grade. All right, they're all linear, so I'm going to subtract 3x. X minus 5 equals 3. Last step is to add that 5. So x must equal 8, which is Spanish for 8. Yeah, fairly certain. Hey, Colton, you went to Puerto Rico. What is 8 in Spanish? Yes, good job, Dave. I'm on it. I'm on it. I'm on it. So you're going to get, I don't know, 6, maybe 7 problems where you have to manipulate the base. And what I mean by that is manipulate one side so that you end up with the same basis. Very good, very good, very good. Yes, thank you. All right, let's try another example here. Danica, give me some random numbers, man. Go.
5,
Yeah, that's right.
8,
Love it.
7.
Okay. No, I don't want a 6 there. Because of the way the problem works out. Give me a bigger number.
10.
10 works. All right, so where's the variable?
7.
Where is the variable? In the exponent. So what type of an equation are we dealing with?
Exponential.
Exponential. Do I have exponents on both sides here?
No.
No. So I don't have same base situation. And when I subtract the 5 here, 8 raised to the 7 minus x power equals 5. So there's no way to get 8 and 5 to have the same base. Right? So, here we go. I'm going to say it like this. We have a variable in the exponent. We have a variable in the exponent, and we have different prime bases. Right? So I use the word prime here loosely because it's not always going to be prime. But I'm talking about like the most basic form, right? On that last problem, the prime base of 27 is 3, right? The basic base there. All right, so if you have variables in the exponent and you cannot match your bases, right? So I can't have the same base. I would need you to think logs. Yeah, and they were roommates.
Oh.
Isn't it funny how you hear the truth about a kid? You know what I mean? Who really enjoys those types of things as they walk by. Yeah, that's a weird way to out yourself, but it's okay. Like I'm never going to judge that kid for enjoying those types of activities. You know what I'm saying? Like, no judgment here. I support all of our friends. I just, question the way we came out, We came out by walking past Mr. Stevens' class and announcing to the world how much we enjoy those activities. All right. He said he put his blank in my blank. And I'm pretty sure he said I enjoyed it when he put his in my... is what he said. All right, so... that's what I heard.
He's saying it.
Oh, he was doing those Lil Nas X bars? Is that what he was doing?
A little bit.
Yeah. Lil Nas X bars? That's fire. Fire. Did you catch that joke, Will? Very good. All right, so let's get back at it. Here we are. I love that this is being recorded, by the way. So we have 8 to some power equals 5. So once I've isolated the base with the exponent, right, we have to isolate the base with the exponent first. That part's wildly important. Now that I have my base isolated, we're going to take the log of both sides. I like natural logs because I have to write less. So here we're looking at the natural log of 8 raised to the 7 minus x power. What's up, Kieran? And it's equal to the natural log of 5. So property number 3 on logarithms says the exponent comes out front. So I get 7 minus x times the natural log of 8 equals the natural log of 5. The log of a number is a number, and we're going to treat it like a number. So, yeah, I know, right? The log of a number is a number. Just treat it like a number. So here, I could distribute, but that makes things a little bit grosser. So what's the operation between 7 minus x and the natural log of 8? What up? Yeah, how do I get rid of multiplication? Yeah, so if I divide both sides by the natural log of 8, cross that bad boy out, and we get 7 minus x equals the natural log of 5 divided by the natural log of 8. Now, there's a really simple way of handling this. Actually, there's two ways of doing this. I could add x and subtract the logs, or I can subtract 7 and then divide by -1. That part's a little bit more confusing, only because when you divide by a negative, you've got to switch a bunch of signs. So what I'd like to do in this scenario is add the x and subtract the natural logs. So when I add x to both sides, I get 7 equals the natural log of 5 over the natural log of 8 plus x. And then when I subtract my logs, I get 7 minus the natural log of 5 divided by the natural log of 8 is all equal to x. So I want you guys to practice plugging this in a calculator and round it to 2 decimal places. Bless you, sweetie. Thank you, Mr. Stevens. You're welcome. What did you just whisper at me? Emmett, only you and the 6-year-olds in the building today are screaming 6, 7. I'm not going to say anything.
Did my siblings say in calculus?
Who?
My siblings. Were they not in here with angels?
Yeah, no, they were. Bennett and
Sawyer.
Yep. Yeah, no, they were screaming it.
Were they?
Yeah, writing it all over the place.
Were they actually?
Yes. Bennett was like up in my butt. It was funny. All right, what do you got? 2 decimal places. What'd you get? 6.23. All right, Marissa, great job. Let's triple check your work here, homie. So I've got 7 minus. Yep, 7 minus. We have the natural log of 5 divided by the natural log of 8. That's exactly the way it's written here, correct? And then when I hit boom, we get 6.23. Hey! Let's go! Emmett.
Yes.
What does this squiggly equal sign mean?
Not the famous clue.
Okay. That means, okay, so you did have the right answer. You just went with, I have no clue whatsoever, here's the right answer. I need you to understand. Oh, wait, that was you? So he had the right answer, you had no clue.
He had no clue.
That was
then I
my
said
guess,
it.
but
Oh, okay. I thought Emmett, I thought you said, I haven't the slightest clue, it's approximate. Like, that, you have to understand, as somebody who studies logic, quite often, that hurts my brain. That's right up there with, hey, Mr. Stevens, I have a question. I don't get it. That hurts. It hurts my brain. You announce that you have a question, and then you give me a statement, and my brain goes, I don't like that. It hurts. That hurts real bad. 95% of the other teachers in the world go, oh, well, then let me do a whole lot of work to try and get you to figure it out. I want you to do more work. Tell me what you don't understand. Approximate. Okay? Which means we've rounded. All right, so there's 2 different things happening here. One, if you have the same base or the ability to manipulate the same base, then you just set your exponents equal to each other. The other situation is whenever you do not have the same base or the ability to get the same base, then we use logs. Okay? We're going to do one more example. I want to show you the algebra, and then the rest of the day is yours. All of your homework has been assigned. Maddox, did you finish it already?
What are you doing?
That was indeed intimate. Kim, I need a bunch of numbers. Give me some numbers. Go.
no.
Yeah, good.
9, 2, and 3.
Let's just go with 3. I like that. That 23 looked like 2 times 3. I keep it simple. So 8 raised to the 9x plus 1 equals 3 raised to the x power. Oh my. So you're going to have a homework problem exactly like this, but with different numbers. Obviously, Kim didn't write Savis, whatever it is. What? No, Kate, what is happening? Okay. So, do I have the same base?
No.
No. Do I have the ability to manipulate these into the same base?
No.
3, 9, 27, 81. 8 doesn't touch any of those numbers. Okay? All right, so here's what we do. We introduce logarithms, right? You need to think logs. If I can't have the same base, I'm going to introduce logarithms. I use natural log because it's easier to write. 8 raised to the 9x plus 1, and the natural log of 3 raised to the x power. Now, pay mighty close attention. We are going to go through some algebra here.
Okay.
We're about to go through some algebra that will show up on this homework, and I will be putting this on your quiz Friday. Okay?
Yes, sir.
So this algebra is very important to me because this, I think, distinguishes the middle pack to the upper pack. So if you can get this concept, and you can understand when to recognize this concept, it's going to set you up for the rest of your mathematical career. I saw this in calculus. I see this in differential equations. Every math class after this, you're going to see it. I promise. So let's pay attention to what happens. I have the log with an exponent. Property 3 of the logarithm says the exponent becomes a multiplier. So that exponent comes out front, that exponent comes out front. Now that exponent is a binomial, so I'm going to put it in parentheses, 9x plus 1, times the natural log of 8, which is just a number. And it equals x times the natural log of 3, which again is just a number. So, how many terms have a variable? Yes. So I need to recognize 2 or more terms with the variable. 2 or more terms with the variable. So I have to break up this binomial, and I can do that with distribution. So I'm going to distribute my natural log of 8 here. When I do, I get 9x times the natural log of 8 plus the natural log of 8 equals x times the natural log of 3. Now, this is a 3-step process, and we'll be done at the end of these 3 steps. We are going to isolate, factor, and divide. It's the Independence Fire Department of mathematics. Isolate, factor, divide. So I want to isolate all the terms that have an x on one side. So I have the 9x natural log of 8, x natural log of 3. I want to get those on one side, and I want to get everybody else onto the right-hand side. So when I subtract x natural log of 3, I will also subtract the natural log of 8. So we get 9x natural log of 8 minus x natural log of 3 equals negative natural log of 8. So we've isolated. And now we factor. What do all the terms on the left-hand side have in common? X. X. So I'm going to factor out these two x's. And so now I go from 2 x's in my equation to 1x. 9 times the natural log of 8 minus the natural log of 3. And it's all equal to negative natural log of 8. This is how we take 2 terms with x and turn it into one single x, right? Our goal in the end is to have x equals. And now we're one step away. What did the D stand for in IFD?
Divide.
Divide. So I'm going to divide both sides by 9 times the natural log of 8 minus the natural log of 3. As such, hey guys, and when we divide that cancels out to 1, so we're left with x equals negative natural log of 8 divided by 9 times the natural log of 8 minus the natural log of 3. Alright, practice now. Punch this in the calculator to make sure you get the right answer. I want everybody to practice what it's like to punch this in a calculator, rounded to 2 decimal places. Emmett, will you grab Kimmy a calculator, please? Is the thunder rolling? Is anybody else feeling Garth, or just me? Nope. Little Garth Brooks. And the thunder roll, and the lightning strike. Another love grows cold on a sleepless night. My love grows on out of control. Something in the thunder roll. Hey, did it turn out that he's the leader of a cult that murders people, or is that just me? Did I find that?
I think I heard that.
Is that true, or is that false? What do you think? Are we going to spread rumors about Garth Brooks? Is he not?
What cult is that?
I learned it at your mama's house.
Which one?
No, not your mom's house, but your mom's house, the podcast.
Oh.
Oh.
You're welcome. All right, what'd you get there, Marissa? Really good job, homie. All right, so that's what you should get when you throw that thing in a calculator. Negative 0.118040, blah, 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 blah. 2 decimal places is negative 0.12. They should be what you get.